So let's look at this question. If the abundance of lithium 6.0151221 atomic mass unit is 7.500% and the abundance of lithium 7.0160003 atomic mass unit is 92.500%, what is the average atomic mass? So what we are going to do is to take the relative abundance 7.5, we divide it by 100, multiply it by the 6.015121, then plus the relative abundance of this, that's 92.5000 divided by 100 times 7.01600003. So that is going to give us this, and we will take the addition of the 7.5 divided by 100 times 6.015121 plus 92.5 divided by 100 times 7.01600003. Our result is going to be equal to, so for my calculator I have 6.9409 atomic mass units. So the correct option is option D. So the correct option is option D. That's the correct option. So let's move to the next question. Which of the following has the largest radius? So if you look at these are ions. This is calcium ion, this is potassium ion, sulfur ion, and this is hydrogen. Now the ionic radius increases down a group and decreases across a period. So as you move from left to right across your period, the ionic radius decreases because you are going to have more nuclear charges than the more negative charges than the proton. So in this case, potassium is going to have the highest, the largest radius. So the correct option is option B. Our next question is to look at this. The question says, which of the following pairs has two unpaired electrons? So for us to get which of them has two unpaired electrons, we have to look at the electronic configuration of the various elements present here. So this is the electronic configuration of iron. The A arrow here you have here is the electronic configuration of argon, meaning that all of this has 18 electrons in it. So have 18 plus 6 in the d orbital. So you know that argon has its electron filled in the p orbital. So this ends in the p orbital, 18 electrons plus 6 electrons in the 3d orbital and 2 electrons in the 4s orbital. So if you look at this, if you take away the electronic configuration of argon and you have this, you have 4s 2 electrons here, then I have 6 electrons here. So you know, according to alpha, you have to fill this electron singly. You fill this 1 2 3 4 5 including this, then you come back and fill this again, then we fill this. So we have 4 unpaired electrons here. So these orbitals, these 3d orbital, this and this are unpaired. So we have 4 unpaired orbitals. So that rules out ion option D from this option. So this is clearly out of it. So let's check for other elements. Next is the electronic configuration of sulfur and magnesium. So this is the electronic configuration of sulfur. Sulfur is clearly a p block element because all the electrons ends in the p orbital. So if you look at this, you will see that the 3p orbitals, the px orbital, the py orbital and the pz orbitals are unfilled. So So we have two unpaired electrons here. So sulfur has has two unpaired electrons at the p orbital. So let's go back to the option and see what we have there. So therefore it means that option X and option B are possible answer. You know, we have sulfur in D, but because iron does not have two pairs unpaired electrons, it has four. Then that is that. So we are going to narrow our search down to B as okay. Let's check for magnesium, whether magnesium also has two unpaired electrons. Now this is the electronic configuration of magnesium with 12 electrons. Now if you look at the electronic configuration of magnesium, you will see that the 1s is filled, 2s is filled, the 2p3 is filled, 2px orbital is filled, the 2py orbital is filled, the 2pz orbital is filled, and the 3s orbital is completely filled. So magnesium has no unpaired electrons. So that means option A is ruled out. So option A is ruled out. So our next option is B and C. So okay, also option A is ruled out and option B is also ruled out because we have magnesium here. So we have to check for silicon. So once silicon, we find out that silicon has two unpaired electrons, then our answer will be option C. Remember, we already know that sulfur has two unpaired electrons, which are these are the two unpaired electrons. So this is the electronic configuration of silicon. So you can see that at the 3p orbital, silicon has 4 electrons. At the 3p orbital, you will find that we have two unpaired electrons here. So our correct option is option. So option C is the correct answer. So the correct answer is option C. So our next question is this: the value of Planck constant is. So we have to give the value of Planck constant in calorimeter per second. So one Planck constant is actually equal to 6.63. It's actually equal to 6.63 times 10 raised to the power minus 34 joules second, or you can approximate to 6.625 times 10 raised to the power minus 34 joules second. So if one calorimeter is equal to 4.184 joules, then 6.63 times 10 by 4 joules second will be equal to 6.63 divided by raised to exponential raised to power minus 34 divided by 4.184 calorimeter cal second times per second. So when you divide this is going to give us 1.58. This is going to give us 1.58 times 10 raised to power minus 34 calorimeter seconds. So the correct answer option is option B. Question 16 here. This question here, the values of spin quantum timber is supposed to be the values of spin quantum number can be plus 1.5 or minus half. So it's plus 1 over 2. Quantum spin is given as 1 over 2 or minus 1 over 2. So these are the values for quantum spin. So next is the correct ground state electronic configuration of chromium. This is the correct ground state electronic configuration of chromium. Now from 1s2 to 3p6, that gives the electronic configuration of argon, which is 18 electronic configuration. So after the electronic configuration, now for writing the electronic configuration of transition element, you write the 3d orbitals first before you write the 4s orbital, and this is the more stable state for chromium. So you, instead of having 3d for 4s2, you are going to have 3d5 4x1. So the correct option here is option D, which is argon 3d5 4x1. Remember that this argon stands for the electronic configuration of 1s2 to 3p6, which represent 18 electron, which represent 18 what electron, because argon has 18 electrons. So next in that line is this question: if 4.0 gram of gas occupies 11.2 liter at 0.0 degrees centigrade and 0.25 atmosphere, then the molecular mass of the gas is. So what you need to know here is this, that at STP, the volume of a gas is 22.4 dm cube or liters. 22.4 dm cube or liters. Now the conditions given here are not in standard condition, they are not in standard temperature and what pressure, because the standard pressure should be atmosphere, but we have a standard temperature here 0.0, which is the same as 273 Kelvin. So what we are going to do is to keep the temperature constant, because it should be at STP. So when we keep the temperature constant, we are going to look for the volume of the gas at volume of the gas when the pressure is what 1 atmosphere. So at 1 atmosphere, the volume should be 22.4 dm cube. So that is what the volume should be. Now by using this relationship, 4.0 gram of the gas occupies 11.2 liters at 0.25 atmosphere. So what we are going to do, and they now ask us to do for the molecular mass of the gas. Now the reacting mass of that gas is 4 grams divided by the molar mass of the gas, which we have to look for, is going to be equal to the number of moles present in that gas. So that is equal to volume of the gas all over the molar volume of the gas, that is 22.4 liters. 22.4 liters. So we have to get the value of this V right away. So how do we get that? So by keeping the temperature constant, we are going to look for the new volume at 1 atmosphere. So what we are going to do is we are going to use Boyle's law to get this. So from Boyle's law, we know that P1 V1 is equal to P2 V2. So by doing this, by using Boyle's law, P1 V1 is equal to P2 V2. So because these conditions are not in standard condition, because of this atmospheric pressure here 0.25, so we have to take it to 1 atmospheric pressure. So we want to know the volume that it will occupy if it is what 1 atmospheric pressure. So what we now did is P1 V1 is equals to P2 V2. So my P1 is 0.25 and my V1 is 11.2 liters, which is equal to P1 is 1 atmospheric pressure, because I want the conditions to be in atmospheric pressure so that we can use this volume here. So V2 is what we have to calculate. So by doing that, we make V2 the subject of formula. 0.25 times 11.2 is equal to 2.18 liter. So when we divide, so 2.18 liter, this times 0.25 times 11.2 is 2.18 liter. So V2 is equal to 2.18 divided by this one. That is going to give us 2.8 liters. Now, haven't gone that, we can now go back to this place to look for the mass. So from here we can say that 4 divided by m is equal to the reactive volume now. So for my calculation, the reactive volume is this is 2.8. So I have 2.8 divided by 22.4. So I'll just divide that out. 2.8 divided by 22.4 is equal to 0.125. So I can say 4 divided by m is equal to 0.124. 0.125. So making m the subject of the formula, m is going to be equal to 4 divided by 0.125, and that is going to give us 32 grams. So if you look at the option C is the correct answer. Option C is the correct answer. So option C is the correct answer. So let's move forward. So we have this question: an atom having a mass number of 65 and electronic configuration of argon, 3D. Okay, this question is a bit not clear. 3D 04S2 contains how many electrons? Okay, I think I have 3D2. It is 3D2. Argon has 18 electrons plus the 2 electrons in the d orbital, that's 20, plus the 2 electrons in the